Welcome to module 13 of object analysis, object oriented analysis and design. In the last two modules, we have discussed about the nature of objects and their interrelationships between them. In the current module, we will start discussing about the nature of classes. What is an interface and what is an implementation will be the major items to talk about. So, we will try to understand those from the perspective of a class. Here is the outline which will be available on the left hand side of the presentation all through. Now, I am sure most of you have certain strong idea about what is a class. Still we would like to more formally define that. We have, since we are talking about object oriented systems. So, certainly we know that the core of the whole system are objects, and we have seen, we have defined that what is an object, and we have seen the object has state, behavior and identity. So, object necessarily is a concrete entity that exists in time and in space, we have seen that. Whereas, a class which is closely related to objects is somewhat an abstraction, somewhat of an abstract concept, which tries to capture the essence of a set of objects which have strong similarity, strong commonality in terms of their structure, behavior and semantics. So, for example, if we consider say a class faculty, then we will say that it has, let us say for example, 3 different objects, 3 different names of professors, their designation and the department that they are associated with. So, each one of these are objects because they have a concrete existence, whereas this class faculty abstracts these objects in terms of the name, designation, department and of course, a lot of other behavior, lot of other operations that will be common to all these objects. So, to put in place a class is a set of objects sharing a common structure, common behavior and common semantics. So, when we talk about the commonality of the objects in a coherent manner, we refer to the class. So, it is kind of like a template according to which every object of that class have to correspond to, have to adhere to, have to conform to. So, we will say that given any class, an instance of the class is an object. Okay. Now, of course, this is a very nice cartoonist view of what is a class. You can look at it, enjoy that. Now, if we want to also ask what is not a class, then certainly we will observe that an object is not a class, or the objects, a collection of objects which share no common structure, common behavior, they cannot be grouped in terms of a class, because the class by definition has to have the common structure and semantics and behavior. For example, if we just look at say today's newspaper is an object, Bajrangi Bhaijaan movie is an object, state of West Bengal is an object, these all are objects, but they cannot be put together in a class. So, the class will specifically be in terms of that sharing, and beyond that what a class can be is a matter of experience and expertise of the designer who is designing the class. Of course, it is possible that if we are talking about an organization as a whole, we could theoretically at least represent the whole organization object as one class. Such a class would be so complex, it will have so many different types of interfaces catering to employees, to customers, to vendors, to regulatory authorities, to the management and so on, that it will practically become very difficult to deal with, to understand, to analyze such design of classes. So, the point that I would like to remind you about, that while we talked about the analysis of complex systems, we learnt that a complex system should typically be analyzed, be designed in terms of its attributes, 5 typical attributes of hierarchic structure, relative primitives, separation of concerns, common patterns and stable intermediate forms. I would just like to remind you, and if needed you can go back to that corresponding module and look at that video. The similar, now it is the time that we use these attributes in design of the classes, and that will decide what is and what should not be a class. Now, a class typically has an interface and an implementation. I am sure most of you are familiar with these two terms, but to introduce these I would like to take a little tour of what is known as design by contract. Design by contract is kind of a metaphoric approach where the concepts are borrowed primarily from the business domain, where their clients and suppliers have to work together for getting certain products, and to be able to work together they have to agree on a contract where the client has certain obligations, the supplier has certain obligations, and the client gets certain benefits, the supplier gets certain benefits, and both of them together comply to the contract and keep within the law of the land. Now, the reason I refer to design by contract is the fact that when the methods of object oriented analysis and design were evolving and was getting strong grounds, then it is in the middle of 80s where the design by contract was originally proposed by Burton Mayer, and that has proved to be a very effective approach in solving a wide variety of software design problems, OOAD problems and so on. So, if we just look at it in terms of the terminology or points, that there between the client and the supplier there will be mutual obligations and benefit, and in terms of the contract the supplier must provide a certain product which is the obligation of the supplier to the client, and it will expect to have a benefit from the client, which is the fees that the client pays. Similarly, the client must pay the fees, which is the obligation of the client, and is entitled to get the product, which is the benefit that the supplier provides, and both of them have to go by the obligations of the laws and regulations, which is a part of the contract. So, this is the basic concept that design by contract says. This still is completely in terms of the business domain, but please note that design by contract, or DBC as is commonly called, has found wide applications in software design, in software automated software documentation, particularly in designing inheritance, polymorphism, exceptions and so on. So, we will come to those specifics later on. Let us see how do we apply design by contract more directly into a software design or a class design. We say that please take a look into this diagram. Here we are talking about a software component which could be thought of as an object. It could also be a simple procedure or a function. So, we say that this component, this object or this particular method of an object is requested with a message with certain input values. So, what will happen if a message arrives to the object for a particular method, then that method will take those input values and start executing. So, that is what is the software component is trying to do, and then it will produce output. Now, in the process it can also create some side effects. Certain other things could happen, like there could be some errors, there could be some exceptions thrown and so on. Now, what we are saying that in a good object based design, the input values must satisfy a set of preconditions. That is, the client, you remember this, our basic model is client server. So, the client who is sending the message to the server to invoke a message must make sure that the message is good, must make sure that a set of preconditions are satisfied by the input values. At the same time, there is a set of post conditions that must be satisfied for the output values. So, in response to the client's message, the output that the server generates or the response message that the server generates must satisfy a set of post conditions. Now, if these two are guaranteed, then certainly the client and the server can work in a lot more safe and segregable manner. So, precondition is to be guaranteed at the entry, and the client must do that, because this is where the message is coming from. So, it is coming from the client. So, it is the obligation of the client to make sure that the precondition is satisfied. Against this obligation, what benefit does the server get? The server gets the benefit that it now knows that the preconditions are satisfied. So, while it is implementing the software component, while it is implementing the method, it does not have to think about any situation which is not protected by the preconditions. It can limit itself to just the preconditions. Similarly, post condition is guaranteed on exit from the message, on exit from the routine, and it is the obligation of the server to ensure that, and certainly that is a benefit that accrue to the client, because he has been able to invoke the message and get a successful execution. And in this whole process, the client and the server must maintain that the class has certain invariants, certain things should not change, should not be violated in the class, all those must be maintained. So, if you see the style of specifying this design or building up this framework of design by contract, you will immediately be able to relate it to the typical business scenario of obligations and benefits catering to the precondition, post condition and the invariance in the class. Okay. If this is somewhat sounding difficult to you, sounding somewhat vague to you, we will soon come up with an example and explain this design by contract more. But before that, let me introduce what is an interface. We have talked about interfaces even earlier a number of times. So, you understand that an interface basically provides an outside view, that is whatever an interface of a class, and which will by instantiation will become kind of an orifice through which an object can be operated on, is necessarily an outsider's view, what someone from outside that object, someone from outside that class can see. And the abstraction and encapsulation will ensure that all the details, the structural details and the secrets of the behavior will be hidden behind this interface view. Now, interface naturally has to apply to all instances of the object, all instances of the class. So, if I say that a class has certain interface, then every object that I create of that class, every instance that I do, that must satisfy the interface. So, what does the interface has? Certainly, this is what you clearly know, that it must have the methods. The methods must be publicly visible. We have talked about visibility in terms of objects. We will see what does it specifically mean in terms of classes. But in addition to the methods, what is important, and this is the concept we are borrowing from design by contract, is the interface has contracts for methods, has certain precondition, post condition guarantees certain side effects of whatever that interface will do. So, interface will simply be the methods, publicly visible methods, and the contracts of these methods. Let us take an example. Let me consider a stack. I am sure all of you know stack, you know it is a LIFO container, last in first out. So, you can add members to a stack by push, remove members from the stack by pop. If you push, they keep on getting stacked, and when you pop, it is the last pushed element which will get extracted out of the stack. So, the order in which the elements enter and they leave the stack are opposite of each other. Besides, so that gives us the two common methods that a stack has, push and pop. In addition to that, typically we will have another method, another part of the interface which is top, to know what is the current top element of the stack, and we also have a method empty to check if the stack at all has anything. So, we understand this. So, given that if we are designing a stack class, we will say our interface, the method part of the interface are these 4 methods. There must be a way to push, pop, top and empty. There could be several other interface functions, there could be several other methods also, but this is minimum for defining a LIFO, this is minimum for defining a stack. Now, let us look at, for each one of these, let us look at the preconditions and the post conditions and the side effect. So, this is the method part, and what you see in the rest of the table is a contract part. This is a contract part. So, contract. So, in the contract what we have? In the contract we will need to have preconditions. So, if we look at push, let us say, let me pick up another color. So, if I look at push, then what is the precondition? That is, when the push method will be invoked on the stack, what the stack object, the particular stack object can assume. The stack object would like to assume that the object that you are trying to push, if you are doing a push, then you have some object that you want to push. For example, it could be a stack of integer, then you are trying to push an integer. It could be a stack of strings, then you are trying to push a string. So, of course, the say a stack of integer object, while push is invoked on that, we will expect that you give it always an integer object, you do not give it a string object or an employee object or something like that. So, the fact that the object will have to be valid is a precondition for the push. Now, what is the post condition? What must be satisfied when the output is generated by push or when push message actually completes execution? Naturally, the object that you have given to push, that must exist on the top, otherwise the LIFO will not get realized. So, it is very critical that this post condition be satisfied. What is the side effect? Now, it may or may not have a side effect, but it is possible that whatever way we are internally implementing the stack, we will talk about this more when we come to the implementation part of the class. But whatever way we do that, we need memory to keep the elements. So, if we repeatedly keep on doing push, at some stage we will need more memory and that requirement will come up to the system. So, that is the kind of side effect that we can have. So, if we similarly look at pop, we will need the fact that I can pop an element provided there is some element in the stack. So, the precondition of pop could be thought of as the stack not being empty. Naturally, post condition is top object has been removed, and certainly pop may release some of the memory that was used by the last object. Top again will need a precondition that the stack is not empty, only then you can get the topmost element. Certainly, its post condition is it must return the top object, that is what I am trying to find out. And the other post condition is in the effect of doing a top should not change the state of the top stack object. The state of the stack object must remain unchanged. So, there are two post conditions and there may not be any side effect. If you look at empty, we can say that there is no precondition. I can send an empty message to any stack, whatever it is states, and the post condition is the state of the stack does not change, there is no side effect. So, this is the view of the methods and the contract, which together form the interface of the stack class. I would like to warn you, particularly those who have already been writing programs in various OOP languages like C++, Java or Python for that matter, that you would tend to often believe or follow that it is only the methods, only this part is what is the interface. But please understand that if I just know the methods, just know the messages that I can send to the object to invoke these methods, then I will not be able to do the task properly unless I am careful about the precondition which is specifying the properties on the input, the post condition which specifies the properties on the output, and the side effect which can happen during this process. Just to understand that, let us say, let us take for the stack itself an alternate interface. In this alternate interface, again the methods are same, I am not changing any of the methods. But what I have changed is I have changed the contract. Now, I say that well, in the contract I do not expect that when pop is invoked, when a message is sent to pop, then the client has guaranteed that the stack is not empty. I might ask for doing a pop or a top on a stack which may not be empty. I will say that there is no precondition. So, which means that the stack could be empty and I may be asking for a top. So, what will happen? Now, certainly if the stack is not empty, then the top object is removed. So, that is same as what I had. If it is not empty, then some memory may get released, but what if it is empty? Naturally, the output cannot be generated or the output cannot be satisfied because there is no top object. So, what I will do? I will throw an exception. Throwing an exception is, we will explain that more later on, is kind of telling the system, telling the client server system that well, I was asked to process a message which I was not able to do. So, in turn I send an exception message to some exception or error handler, error controller. So, it will, since in the just consider that in the previous interface the precondition said that stack is not empty. So, it was not necessary to consider a side effect where pop could throw an exception of stack being empty. But here I have changed the precondition and therefore, I have a possibility of a side effect where an exception may be thrown for the stack being empty. Similar thing will happen for top, it could also throw an exception if the stack actually is empty, is when you are trying to invoke the top message for that stack. So, you can see that just messages being the same does not actually give us the same interface, because depending on the contract here and the contract here, the way the programmer has to implement these methods would be way different. We could think of yet another interface. So, in this interface again we have the same set of methods, we have the same kind of preconditions, and what we change is we have added in this interface, we have added a specific side effect for push. Here we said that push may create a side effect that I need memory, push may create a side effect that more memory is needed, push here as well will create a side effect that more memory is required. Now, stack theoretically is unbounded, I can keep on stacking as long as I want, but whatever system I actually use to implement the stack object will finally have a limited memory. So, at some point it will run out of memory, it will become low memory. So, what will happen to that? So, compared to this interface, this particular one, the later one is a more well specified interface, because it takes care of a potential situation that can happen in the system when it actually has very low memory to make a push request, push message actually successful. So, this was this example I am sure have shown you how you really apply the design by contract principles in terms of your interface design, and how really different interfaces having the same set of methods, but having different kinds of contract will impact the whole design process. The next that we would like to draw your attention to is, we mentioned that methods are publicly visible. I would also remind you of the fact that we have repeatedly been saying that we will enforce encapsulation of the objects, and certainly since objects are instances of their classes, the classes must have a mechanism to encapsulate. Encapsulation basically means hiding certain parts of a class or certain parts of the object that will get instantiated from other objects, from instances of other classes. So, we may note that there are typically 4 types of visibility, or you can say that the interface can be classified, divided into 4 different parts. One, that is called public. This is an interface which is accessible to all clients, anybody can use that, and typically when we talk about a interface for use, like we were talking about stack, this is based on only the public visibility, because anybody should be able to use the push, pop, top, empty kind of interface. Another is a private one, which is accessible only to the class itself, not to the outsiders, not to anyone else. So, in the stack example, we could have a method which actually checks if the stack has enough memory when push operation is happening. Now, this method will not be exposed to the external clients, because they do not need to be bothered about whether what the stack class or the stack object should do when there is not enough memory to push another element. This is an internal matter of the stack class, it is an internal matter of the stack object. But stack object actually by itself need to know whether there is enough memory available or not. So, I could have a full kind of a method which the stack object will send to itself to invoke and check whether there is enough memory. Such a method would be a private method, because that others should not be able to see this. In between, we will also see that there is a class of visibility factors, where a declaration of a method is accessible only to the class itself or to its subclasses. We will come to more of subclasses. We have talked about subclass in relation to abstraction hierarchy. So, if something is a subclass of another class, then protected visibility is for that subclass. So, if something is protected, then it is accessible to the class, but it is not accessible to the outsiders, but along with the class, the subclasses also can access the protected members. Finally, some of the object systems introduce another few other kinds of visibility, like package is one such visibility, where all classes that belong to the same package, which is kind of saying that if I put the classes together under one folder, package is similar in concept to a folder, that all the classes, but it is not exactly a folder, it is somewhat different. But it says that if we put all of these classes into a single package, then the classes would be able to see each other, the classes would be able to will be visible across each other. So, we say that visibility enforces different grades of encapsulation, from very hard encapsulation of private visibility to somewhat limited encapsulation of protected and package visibility, to complete openness of public visibility into the whole system of objects and classes.